Welcome to the Alaska Energy Training Group. My name is Jenny Stars, and I work at Renewable Energy Alaska Project on our Alaska Network for Energy Education and Employment. REAP is a nonprofit that works statewide to promote energy efficiency and renewable energy. And Annie specifically really works in this same field that many of you do in helping connect people in training and technical assistance and troubleshooting throughout energy in rural Alaska, in the rail belt, in Southeast. I'm joining today from the unceded homelands of the Dena'ina people in Anchorage, Alaska. If you all could introduce yourselves in the chat, that would be great. Please introduce yourself with your name, your organization, your location, and if you want to share anything about your role in our shared mission of troubleshooting, training, and technical assistance, that would be most appreciated. And as you're doing that, I'll just give a brief overview of our group because we have some new faces here today. The Alaska Energy Training Group's mission is to improve coordination and collaboration in those sort of three buckets: the training, technical assistance, and troubleshooting. And just broadly in infrastructure investments that are hitting Alaska right now. We really want to address some of the capacity challenges that our joint programs and endeavors are facing, and also really leverage the influx of funding. And the group is facilitated by REAP in partnership with the Alaska Energy Authority, Denali Commission, and Alaska Center for Energy and Power. So definitely a collaboration. And we're always open to ideas from participants about topics and things that would be most beneficial for you. Today, we'll be hearing from experts from AEA, TotalView, and ANTHC. And we'll be talking about imaging and monitoring of rural infrastructure. So during the presentations, if you could share any questions in the chat that you have, we will leave time after both presentations to get into some more of your targeted questions. But if some come up during the presentations, please feel free to share them in the chat. And then we'll save about 10 minutes at the end for participant updates and any other group housekeeping, like our next proposed meeting time. So with that, I'll kick it over to Chris McConnell, Annie Director. Oh, you're muted, Chris.
A classic mistake. And welcome everybody. I'm actually at the Clean Energy Summit, the Department of Energy, Indian Energy, in Temecula on Luiseño tribal lands. And it's sort of timely because a lot of the clean energy projects depend on a lot of the folks that I think are interested in this conversation. So I'm going to keep this short and jump right into our speakers, but just framing things a bit, I think it was Lord Kelvin who said something along the lines of, you can't manage what you can't measure. And I think that when it comes to caring for our infrastructure, it's sort of that monitoring piece, because of technological advances becoming more and more powerful. Broadband is getting more ubiquitous through rural Alaska. And I think there's a set of tools here and some Alaska organizations that are really on the edge of certainly remote technical assistance, troubleshooting. And so I want to highlight some of their work today. I'm going to jump right into things and introduce Bill Price, who is the Senior Infrastructure Manager over at Alaska Energy Authority. And they're doing really some incredible work in terms of imaging, and I'll let him take it away from there. And I believe in partnership with Arthur Jensen of TotalView, a firm that has done some of the behind the scenes work there. But Bill, why don't I let you take it away and tell us what your team's been up to?
Yeah, so Arthur's pulling up the I'm going to blow through these slides because there's a lot of them, and most of what we're talking about is imagery anyway. But what we do at the energy authorities, we focus in rural infrastructure, we focus on the tank farms, the power plants, and the distribution systems. We try to do as many distribution systems as we can, but they're usually pretty low on the totem pole. This year, we're in the middle of our bulk fuel inventory and assessment. A few years ago, we did a power plant inventory and assessment. The object being, one, to inventory what's out there and determine, for lack of a better phrase, the worst facilities in the state, so we can rank them and prioritize funding to address the most needed states. Go ahead and slide. Move to the next slide. So one of my hobby horses is bulk fuel is oftentimes overlooked, but in my estimation, it is the most important piece of infrastructure in the village, bar none. Nothing works without tank farms in Alaska, and they're frequently overlooked in infrastructure. Go ahead. They're fundamental. I mean, I don't know if we need to go a great deal into this. Go to the next slide here. Like I said, I'm going to blow through this, but here's some of the, these are very rough statistics, but this is kind of puts a picture, a snapshot on where things are. Something like 400 bulk fuel facilities in rural Alaska, depending on how you define them, varying in sizes from up around about 100,000 gallons each on average, give or take. These are not hard statistics, but just gives you a picture. They're 40 to 50 years old on average. They're not all that old, of course, but some of them are 60 or 70 years old. Most of them are threatened in some manner, either by maintenance, deferred maintenance, flooding, erosion, thawing, permafrost, all of those things. Each facility is $4 to $10 million to replace them. And I just took a very high level swag, but I think if you were to bring every facility up to code in Alaska, you're talking something in the neighborhood of $1.5 billion in deferred maintenance, and many facilities, and we'll show some. Go ahead to the next one. We got a couple examples here. This is a tank farm that we got a little video that Arthur's going to play. This image was taken a week after the high point of a flood event last year. And you can see in the video when it comes up, the image kind of at a high, it's stumbling a little bit, but this facility did not actually overflood. It did not actually go over the walls. But as you go through there, you can see the water level, which is about 4 feet down from the high point and about 10 to 15 feet above the normal water level. And this tank farm, that's the condition of the tank farm. That is, and believe it or not, that's not the worst tank farm in the state. You notice that up on top, that's how they go from top to top. That's how they transfer fuels with a gas-driven pump. They have a couple dispensers in this community. One of the dispensers is a fill-right pump connected to an old train car. And so that's the level of the infrastructure in Alaska when you're talking about tank farms. And what we're doing with this assessment is we're getting 3D images of all of these facilities, which gives us the ability to take an inventory of the equipment, gives us the ability to see the condition of that equipment. We rank it, we put a score together, and we ultimately build a list that we use for funding and for support of these villages. Let's jump to the next image. As you can see right there, that's the train car. It's quote unquote contained. That little white shack houses a fill-right pump. And that is their gasoline dispenser in this community. I can tell I don't want to put the community on blast for their facilities, so I'm intentionally not mentioning it. Most of you may know which one this is, but that's the river that you're looking out, and it's about 10 to 15 feet high. And this is probably the 4th time this community's had this kind of a flood. So let's move on to the next one.
And I apologize, I'm just switching back and forth from the presentation to then we've got the videos for walking through on YouTube on AEA's channel. So it's playing a little bit slowly right now over the internet connection.
So we've got similar data from all of the tank farms and from the power plants. This is another facility. This particular facility is the next one we're going to try and replace. When the video comes up, this particular facility is threatened by flooding every fall, not spring. When the ice comes in and the ice goes after the facility, it gets blown in and actually takes out the fence, damages the tanks and otherwise. In the interest of time, I don't know how much I really want to go into more of that, because I can bloviate on about this for a long time. Let's go back to the presentation real quick. And let's just go through some of the slides. And again, if we have more time at the end, we can go to villages and we can fly through multiple. We're currently about 60% through, which is something around, I think we've got 150 to 170 images of tank farms, and we've got some preliminary rankings. We've got, and we expect to have the entire list done by the end of this year. Next slide. So here's some of the environmental risks we run into. That's that same old train car that I was pointing out, looking at it from a different vantage point. You can see the spill containment. Sometimes they have it, sometimes they don't. The tanks often are sitting in water because of, depending on when you're there, sometimes they're good about getting the water out of the containment. Sometimes they're not so good. Sometimes there's oil sheen in it. Sometimes there's not. And go to the next one. That's that same community. That's another quote unquote facility. That orange tank actually floated over next to that white tank. It's not supposed to be there. You can see the water, the rusting. Next slide. You can see electrical wires, the snow, the wiring, one of the things I'll speak to electrically, one of the most expensive components to replace and most difficult to replace is the control panels that operate these facilities. The one on the left over there, we didn't actually, that's not the one I'm thinking of, but we were doing some work in a community here recently where we really should have replaced the control panel, but we couldn't. We didn't have the $50,000 just to get the control panel there, not on top of the effort to replace them. So oftentimes these control panels just continue to exist. And you can see in these images, oftentimes they'll end up using knives, screwdrivers, whatever they need to do in order to make the contactor close, or in order to bypass whatever they have to bypass in order to get their fuel, because they'll get their fuel out of that tank one way or another, because if they don't, things freeze and the power goes out, and that sort of those sort of contingencies that are all bad. Next slide. So obviously we've got fuel contamination issues. There's water in the fuel, dirty fuel. The gauges themselves, if they're 50 years old, they're probably not functional. Next slide. And this talks a little bit about over here on the left, that image was from Typhoon Merbok. That tank happened to be empty and Typhoon Merbok tipped it over. A lot of times the only way the tanks don't move in these type of events is if they're full of fuel. Obviously that's not a great scenario. The poor housekeeping, and oftentimes water gets into these tanks because they'll check the tank and they'll leave the cap off. Go to the next one. Leaky fuel nozzles, contaminated fuel with water, trash. And like I said, not trying to point out, trying to put people on blast, but this is what we see. Next slide, please. Obviously, corrosion is an issue. Next slide. And one of the things we find also, it's interesting, we'll go into a tank farm and you'll bring in engineers or you bring in technicians and they say, well, let's get the tanks inspected. Let's find out if we can use these tanks. Well, oftentimes when we're doing these things, we don't want to know, frankly, because if you send an inspector in, you verify that tank is no longer good, you have to take that tank out of service. And now you're as a state agency, as a professional engineer, as a professional, a industry professional, you have ethical duties to, once you identify a tank is bad, you have to take it out of service. And now you've taken 5, 10, 20,000 gallons of capacity away from a village who may not have enough capacity to begin with. So you're oftentimes trying to thread that needle of how can we utilize a tank that we really don't want to use, but we don't have any other option. Another interesting fact on those tanks on the left there, those are what are known as BIA tanks, Bureau of Indian Affairs, installed in the 60s, 70s, 50s, 60s, 70s-ish. That's how old they are. And one of the things, if you ever touch those tanks, you run the risk of lifting it off the bottom of the tank. Some of them are that corroded. They're fine until you touch them. And so that's the kind of what's going on out there. Go to the next slide. We also have improper configuration. Notice this is, I don't know if this is a gasoline or a diesel tank, but you'll notice a 12-volt battery used to operate the pump, which is obviously a hazard. I've seen that done off of drums. I've seen it done off of 500-gallon tanks. As I said, they depend on this fuel. This is the foundational piece of infrastructure for every single village, regardless of how they get their energy. It is foundational, and they'll get their fuel out one way or another. Next slide. Obviously, we pointed at some of those safety things. I've seen I can think of a tank farm, 30,000-gallon tanks. They're 35 feet up in the air, and they have one ladder that goes up to the top of one of them. There's 4 tanks, and they have a board across the top of those 4 tanks. And they go up monthly and walk across that board year round to check these tanks because their gauges don't work. And so it's ideally they should be doing it monthly. Nobody's died doing it yet. Cross your fingers, but that's, like I said, they will find a way to get across those tanks because they frankly don't have a choice. Go ahead. So how do we use this stuff? One of the I'm going to skip it around a little bit on what the agenda I sent these guys. There's three real good ways we use this imagery. One, like we've talked about, to identify what's out there, determine what we need, how do we allocate funding, and how do we be able to give these, how do we paint the picture for the funding agencies. The other scenario that we use it for is training. We will go and make this make these images available to contractors when we're building construction, where we're working with one of the scenarios is a ANTHC in Seward will be training operators. They can use the imagery from the power plant or from the tank farm in Seward to, while they have the operator from the village, and the operator can be trained on how things should be and also learn how to do it in their facility, which is going to be different than what they're being trained on in Seward. So it's obviously a good training tool there. It's also a tool that the villages can use with their contractors when something breaks. They don't have to describe it over the phone or in pictures or sketches. They can take the contractor to the facility, show them the valve that they need help with, or show them the dispenser or whatever. And so that's a tool that we're making available. It is available to the villages. And we are working on a mechanism, I'll call it, to make that make all of the data we have, whether it be inventories, whether it be imagery, whether it be rankings and whatnot, looking to make that available to all state agencies, make it available to all communities, and make it available to approved contractors, meaning somebody told us that yes, this contractor can have that data. We're not just going to give it to anybody. We're still working out exactly what that's going to look like, exactly how we're going to go about doing that, and such. And that's not an insignificant process, because we're talking about multiple terabytes of data, and I won't spend a bunch of time talking about how difficult that's going to be, but that is our objective, to make it available. At this point, it is available. You just need to call us or reach out to us directly, and we can get the data to you, depending on need. It's just not available without going through us. And all we really do is double check that you're either a state agency or that you're in fact the community and you're the contractor authorized. And so just very low bar for getting that data out. With that, let's go to the RPSU dashboard, Arthur. And so what we I want to give you a glimpse of the dashboard we built for the RPSU database. That'll give you an idea of how we're building a similar database for the bulk fuel. It's just not as well developed as the RPSU database is. But as Arthur surfs through this, you can get an idea of what we're building and what we're making, what we use here. And we use it on a daily basis with power plants. I mean, we're frequently on the phone with communities, discussing with them what they need, and we're able to pull up their exact component, their exact engine, and we're able to provide technical support to those communities live, because we know exactly what they have. And we update these images. We're going to do the same thing with the tank farms. We will update the images anytime there's a significant change made, and we are able to provide that technical support to the communities, which is something between something around 100 communities really kind of depend on us for their technical support. That's basically everybody but AVEC and the bigger communities like the North Slope communities that are fairly self-sufficient. Like I said, we're building a similar database for the bulk fuel. We're also, and I'll mention it briefly, we're doing distribution as well. Could you pull up one of the, maybe Quigilanock or one of those other villages that's a real good showcase of what we can do with distribution? And then distribution's a little bit more of a development process for us. We're still trying to work out exactly how to do this without spending $30,000 per image and survey and whatnot. So the big picture of distribution will result in a 3D image of the distribution system, and effectively will result in a 3D image of the village itself. What this is, and this is something you can pull dimensions on. He's showing multiple layers here. There is a photogrammic layer as well, to where you can fly the village and you can pull dimensions and you can see line sag. You can see if the poles are leaning. You can see transformer tops. This imagery is collected by drone. And so we're really building an incredible tool to support these villages. And again, once we figure this all out, we will be making it available. This is state data as far as we're concerned, and all we're really trying to do is prevent contractors using this as a tool to go fishing for money, as well as protect the community's privacy to the extent we can. And really, it's their village, it's their power plant, it's their tank farm. We're trying to be respectful of that. But ultimately, our goal is to provide a tool for supporting these villages. And to that, before I turn the time over to Luke to discuss our training program, does anyone have any questions?
I think if we can put any questions in the chat.
Fair point. Fair point.
We'll move on to the ANTHC presentations, and then questions.
Okay, let me turn the time over to Luke, because we have one other program that I think is very critical, and then we briefly do a run through our bulk fuel itinerant training program.
Oh yeah, that'd be great. Yeah, Luke, if you could maybe give us, 2 to 5 minutes on that, that'd be great. Thanks.
Yeah, you bet. Hello, everyone. It's Lucas, part of the circuit rider program here at AEA. Past couple years, I've been focusing my stuff on training bulk fuel operators, some hands-on training, traveling to these communities. We use the bulk fuel itinerant training checklist, running through scenarios and training to the O&M manuals, providing information and support on deficiencies we find out there with them, and provide the support they need to hopefully get these things in order and repaired if possible on their own. If not, just providing technical assistance to get through the issues that they're having, whether we're there or not. Also provide training through AvTech and give them the information they need to hopefully have some qualified operators. There's things out there with a lot of overturn and through managers and the operators themselves. So we're just potentially providing them information, showing them where the information is to be successful, and hopefully clean up the areas that need to be taken care of throughout the tank farms in Alaska.
Did you go through we show up, we fill out the survey, and that survey identifies, we use ArcGIS, a survey platform, to do, I don't know if an inventory is the best word, but something of a assessment of how good their training is, correct? And then we train to that. We identify some things to train on while we're there, right?
Correct. It's 35 section. I usually walk them through the survey as well, identifying a fail or pass. And from there, we put our efforts towards the things that need work. A lot of times it's the documentation and paperwork end of it, whether they have their lines pressure tested, and then it focuses also on simple things like housekeeping or equipment, but tend to go through this with the operator and then provide them with the survey after it's done as a guideline to make the fixes they need or put their attention on the stuff that they're deficient in.
Great. Thank you so much. That's a really powerful tool you guys walked us through, and a really community responsive way to walk through trainings and assess needs. So thank you so much. I think now we'll turn it over to Kelli and Gary from ANTHC. If you guys don't mind, introducing yourselves and then kicking off your presentation. Thank you.
Yeah, absolutely. Hi, everyone. My name is Kelli Whelan. I have a couple of quick PowerPoint slides to share here. I am a utility support engineer, and my presentation co-host is our remote monitoring specialist, brand new position. So, what should we do? So ANTHC is the medical or umbrella system for the Native Medical Center in the state of Alaska. And our division, which is environmental health and engineering, is kind of the preventative maintenance side. So we're concerned with keeping people out of the hospital, whether that be through providing sanitation, clean drinking water, also in a healthy environment. So clean indoor air, removing brownfields, making sure that people are informed through our AdChem program or a conference every year. So we don't deal with the medical side, but we're an important part of it. And so my particular department, the Rural Utility Management Services, or DRUMS, has 3 distinct programs underneath it. So ARUC is one, that's our Alaska Rural Utility Collaborative. And they focus primarily on 26 different communities and hone in on those operations and maintenance. So really providing operator support, as well as billing to about 6 communities. And the billing program is really nice because billing collection rates in rural Alaska are pretty low. It's hard to bill your family for water and sewer, especially if it's really expensive. And so by creating a separate agency to do that billing, we kind of hope to increase billing rates and make sure that those utilities are much more successful financially. My program is Tribal Utility Support, or TUS. And so we work post-construction, usually. So we're out there training operators on how to maintain their equipment, maybe doing some small maintenance projects in order to keep facilities going to the end of their expected design life. And then also helping our energy program with energy efficiency upgrades and remote monitoring, which is what the rest of this program is going to be about. Presentation is going to be about. And last but not least is our energy program. They do pretty a full spectrum of different projects. They're out getting grants for energy efficiency, feasibility studies, assessments, as well as implementation projects, and then also trying to expand renewable energy in rural Alaska. So they've got a lot of different pots in the fire and really trying to make sure that facilities are financially successful, again, by reducing operations costs. So I'm going to kick it over to Gary.
Good afternoon.
Sorry.
I'm Gary Easter with the TUS group, the RM specialist. What we're going to discuss is the BMON, which is our remote monitoring system we utilize. So roughly we have around 130 communities with about 3,000 sensors that are installed. And with these sensors, we're actually able to collect data, information through a dashboard or through current sensor values. They send out alerts if, say, for instance, a temperature is out of range to the operator. That way they can better assist with the plants. So there's the beginning of our map. If we want to go to the next one, please. The dashboard here actually indicates some of the information in live process. So you can take a look at the one on Holy Cross. It gives you the ambient temperatures of the buildings, as well as some of the information about the area that it's supposed to be covering. It talks about how the process of the plant is flowing, with whether or not there's heat that's added. And then we go to the report side of things, and it can give us information up to 10-minute variables, and it shows the time that it was actually uploaded within the community and what it is in which group it's actually pertaining to. Let's go to the next slide. These are some of the lower wind sensors that we utilize, and each one obviously is programmed dependent on what it's going to be utilized in. And it's able to send the information to what we call gateways, and it sends through the internet to BMON, which we're able to get that information from. So let's go to the next slide. The communities that we're serving now, we're always adding more to them, and we're also adding a lot more technology as far as the sensors and what we're able to attain, including the BTUs, fuel meters, which are able to pull data as far as usage for fuel, for instance, for boilers, information of that nature. We can also get information as far as how much voltage or watts are getting used within a facility as well, which is good, important information as far as the energy side of things to be able to collect that data. So I'm going to move it back over to Kelly.
Yeah, so the sensors that we're using for most of our data collection are ELSIS LoRaWAN sensors, and they're really configurable. They can take most inputs that don't require power and have a ton of different options as far as what kind of electrical data or sensors they can interact with, which is great because that means we can collect a lot of data pretty quickly. And by having more information, as long as everything is set up right and it's working right, you know, we're getting more information about how water plants are operating. So I used it recently in a technical assistance, just for technical assistance with the community, just kind of looking to see, you know, what their backwash rates are, what their filter run times were, just based off the water storage tank data. It was really useful. And also to verify, you know, what the operator is seeing too. And like Gary said, with the monitoring program, we can set up alerts for different basically set points. If it goes too far one way or the other, the operator is going to get a text message, they might get an email, we're going to get an email, maybe a text message. And the idea is to kind of prevent catastrophic events as much as possible. It's very expensive to fly things up to rural Alaska, and there's always lead times. So especially in the wintertime, that usually ends up meaning a frozen system. So those are the pros for our RM program. Some of the cons are that we have a really short installation timeline. We've got 3 years to put RM systems in all of the water systems in Alaska, and we don't have that many people to do that. We're scaling up, but it's been challenging to kind of keep folks motivated and going. We're in year 2 right now out of 3 total. Part of the other difficulty with that shortened timeline is due to lead times with different types of sensors. You kind of have to pick one and then troubleshoot it and work with it and test it in the field. And so the ELSA sensors have been pretty robust, I would say. Like I said, there's a lot of inputs that you can put into them. They can work with a lot of different sensors. Unfortunately, the pressure sensors that we've selected, the battery life is about a year. We were anticipating a 10-year battery life. Also, with both of those sensors, they don't run on batteries that are available at the store. So it's one of those things where you kind of have to, the communities or whoever is going to financially support the system in the future is going to have to plan ahead to make sure that those batteries are ordered from the manufacturer. Long-term ownership is also a question. We are not sure if ANTHC is going to own the system once everything is installed, or the RMW program or the communities. We're kind of still working that out. And then last but not least, that 3-year time limit kind of, it's led to some issues as far as building grassroots support for the system. Operators mostly have been accommodating as far as letting us put sensors in. And we're slowly starting to see acceptance and usage of the system, but I wouldn't say it's widespread. I think ANTHC and the RMW program, so the remote maintenance worker program at DEC and other health or regional health organizations probably get more use out of it right now. But I'm really hoping over time that operators will also start to rely on the system to help them manage all of their equipment and processes. So please, this is our contact information. Please let us know. If we can't answer any questions today, please reach out.
Great. Thank you so much, Kelli and Gary. That was really interesting. I know I have many questions, but I will start with the ones we have in the chat. And anyone, please feel free to drop them in the chat, raise your hand, come off mute, whatever method you're most comfortable with to ask questions to our very knowledgeable panelists. The first one I saw in there was from Jennifer Everidge about specifically for Bill and Arthur. Is the technology there yet to be able to enter a VR room with an operator remotely?
I took a stab at answering it, but I'm actually defer to Arthur, who's more familiar with the tech than I have, if he wants to augment my answer.
So the only thing I would say to augment Bill's answer is that it's possible on most of the widely available headsets like an Oculus, or I guess they're called a Quest, a Meta Quest 2 and 3 now. Some of the Samsung Cardboard and other lower end headsets you can do it on as well. It's more, you're going to be looking at a 360 picture in a headset there. It's not a lot of functionality past that. Chris McConnell had a extended reality panel that he and Reap hosted, where he looks at some of the work that folks are doing in the state, trying to take this data, turn it into a more 3D type data, either by doing a CAD model or trying to model it with a better scanner than the Matterport scanner. Because like Bill said, Matterport is for doing an inventory and assessment. It's not the scanner you'd want to use for building the most lifelike virtual reality or really accurate thing that you're going to then put on your face and make you feel like you're there in the room. So there are half steps that you can do to put this into VR. They're not going to really impress anyone enough, though, to make a program out of them yet. And I don't know if Chris wants to add on to that at all.
Maybe, yeah, just jump in with a little context. And I think that I saw some of the work Arthur's company was doing probably, I guess, 4.5 years ago, and thought it might have an application to rural Alaska. And so Alaska Energy Authority was good enough to let me get into one of their powerhouses, and Arthur worked some of his magic, and the folks in Bill's department there took it up and ran with it. And in that 4.5 years, I mean, it's obviously come a long way. So to Jennifer's question, Arthur, you were doing a lot of your original work up on the slope. So how are some of the giant international corporations using this technology, when they have so much more capital behind it?
So the North Slope companies, namely ConocoPhillips, because they've got a lot of activity going on still with capital infrastructure being installed and revamps, carbon capture, stuff like that. They're using advanced laser scanners called SLAM units, that stands for simultaneous localization and mapping. I can always pull up a screen of what that looks like, but you guys can go and look up a Naviz VLX3, and I'll put it in the chat here. It's kind of a dorky looking thing that you wear, but it's got 4 360 cameras on it. It's got 2 laser sensors on it. And the thing that you guys have to understand about these laser and these SLAM units is that the auto industry is driving forward those LiDAR puck units. Everyone trying to build a self-driving car or a more advanced driver assist system. The LiDAR pucks are getting better every year, like Chris said. They're getting denser. You're getting a less price for them, so people can put more of them. You can gather more data, and that's what makes a more robust virtual reality experience. Now, the North Slope oil companies and the state-of-the-art stuff that we do for some big budget productions, they still don't use virtual reality, and we do not recommend to any of our clients to use virtual reality, because even with an Apple Pro headset or Vision Pro, or this is the Quest Pro right here, $1,500, these are uncomfortable, even to a millennial like myself, to wear more than 15 or 20 minutes. And that's if I'm really engaged in a game. So to expect to have to charge this thing, you have to have stuff in your hands, unless you're using hand tracking, and especially for some of the stuff that UAF and a few of the interactive media outfits around Alaska are developing. You're going to want to have all the controls for this to replace a filter and do a lot of tasks that you actually need to train someone to do in VR, not just kind of look around and experience it. So those things still require a lot of game development, 3D artistry, animation, and time to make. But who knows, with all the generative AI stuff coming out now to make stuff easier to put in 3D, we may have these virtual worlds to be in sooner than we think. It's just, these are uncomfortable, right? We're going to have to, my professional opinion is, we're going to have material science upgrades, chips that are smaller, glass that is lighter, metal that is lighter. Everything's going to have to be lighter by 50% for me to wear this for more than half an hour. And then I would posit to all of you guys too, even if it was as light as a comfortable ski goggle, and your best Oakley ski goggles. Do you want to wear that for an hour in a hot room, or in a conference room with someone? Is is that really the direction we need to be going? So I asked that of all of you. I'm skeptical until the technology increases in its value proposition. And I think it's going to take 5 to 10 more years for us to have something that people will find compelling enough, and it's going to be low budget enough to actually invest in on a wide scale.
And maybe I'll jump in and maybe ask Bill and Kelli or Gary, in terms of, we know broadband is improving in rural Alaska, but Bill, if there's a user and you need the champion to take up the technology in a community, what is the sort of demands for taking one of those photogrammetry tours or laying out the training if I'm doing that from Tuntatuliak? Or
So you're asking what does it take for them to view it in Tuntatuliak, or
correct. So,
using like a 3D, using the glasses?
no,
Or-
the
Oh, I see. It's not that bad, and that's one of the hurdles we've got to overcome, is that there's a way it can be viewed at using the processor at a remote location, so it's more of a video in the village, or you download it to the village and then they have it locally. That's one of the hurdles we got to overcome. Exactly how do we manage that data? There's the Matter. I mean, right now it's all done on Matterport server. That's do you really want to hitch your wagon to Matterport for the indefinite future? Do you develop your own technology solution? So exactly how to make that data available in the villages is still a bit of a question. But and what we're finding is most of the places are transitioning to Starlink, and getting data back and forth in the villages is not as big a problem as it has been in the past. It's in a roundabout way, they're kind of solving the data transfer problem. It's now back to just straight training.
and maybe, sorry, Bill.
No, I was gonna see if anybody else wanted to comment on that beyond what I just said.
I was just going to invite Kelli or Gary to talk about the sort of BMON software and the way you're pinging data back from the communities, if you could speak to that a little bit.
We actually don't use a lot of bandwidth whenever we're uploading the information through BMON. We've also had similar results with a lot of the communities moving towards Starlink. It's becoming more accessible for a lot of communities, and the results that they're seeing with the speeds are actually really, really quite good. So beyond that, we're hopeful that a lot of the communities will be moving towards that, which probably will aid with the issues they're having with the 3D imagery, because I would believe most things are in 720, 1080p, or 4K resolution. And if I'm not mistaken, go ahead.
No, I'm sorry. I thought you were done, Gary. Carry on.
Oh, the bandwidth is not too awful bad in regards to those videos. Would be along the lines of Netflix, I believe. Go ahead, Bill.
A lot of times what we're passing around are actually links. We're not really passing the video, we're passing the link. And to the power to the operators to be able to give their contractor a link. Now the contractor pulls it up, and the operator can go walk around the community. He's on the phone, and the dude in Anchorage is pulling it up on his side and viewing it on his side. And so that's oftentimes how that data is being used. Or Luke will pull it up in our office, and the community will be walking around the community, and Luke will be walking around the Matterport, and the operator will be walking around the power plant or the tank farm, and they are quasi walking around the same space. That's usually how we end up using it.
And maybe I think there's more questions, but I just want to make one kind of the marriage of these two technologies. A couple of years ago, we piloted some imagery and linking it to BMON in Iliamna, and I think that there's obviously everybody that works in infrastructure in rural Alaska can start to see the applications, and we've actually got in front of a lot of the school districts, and so they have a similar challenge set when they're taking care of the school buildings. And so I just want to again say that I think ANTHC and AEA are not just in Alaska, where sometimes we're 10 years behind, maybe in music and other things, but in this particular case, I think that we're on the leading edge, and I think that it's great to see a lot of this in practice. I know, Arthur, did you have something else to add in terms of data and the footprint?
So just that, you know, like Bill said and others have said, with the advent of Starlink and more broadband reaching the communities, we have more opportunities for people to view the web apps, right? Stuff that no one has to download. You can just go to Matterport's website or ArcGIS's website, and you could be right in the 3D drone. You can be right in the 3D walkthrough, walking around it yourself. The interactiveness of it, you want it to obviously be snappy. If you're walking around, you don't want to have 4 or 5 second pauses. So that's where, if there is some kind of latency issue, and the whole thing with everyone getting Starlink is now more people, more kids will have access to internet than ever before. So you'll get this 150 megabits per second coming in, then everyone jumps on it, playing Xbox, and you know it's going out there to other parts of the community, and you can start to see a lot of lag and reduction in that. So other than specific buildings in the community, like the power plant having their own dish, and then an operator being able to sit down at that for an uninterrupted trunk or bandwidth, having the stuff locally is also important. And Chris McConnell and Reap have bought a couple of just simple gaming laptops, something, they're not as spelt maybe as a Chromebook or something, but something about this size, and it has a GPU in it. I'm sure a lot of people have heard of GPUs because they train AI models, but they also originally were meant for nerds like me playing video games. And that's the same kind of thing, making triangles and a bunch of 3D interactively that a good GPU does. You can run all of this stuff locally on a few different programs on a local computer too. That way you don't have to be reliant on the internet, and you can have a hybrid approach for when the internet is out or running slowly. You still have access to training if someone like Luke Jury or a circuit rider comes in and you want to look at something in 3D just to get a better idea of it. So but definitely that's also how the big industrial companies handle it also. When they all went to the cloud, they found that you have to deal with cloud latency, right? If you're up in Tuntatuliak or Shishmaref, your server for Matterport is in Virginia or Washington. You have to wait that many more milliseconds of latency before you're turning around your head in the photosphere or before you're walking ahead in the 3D. So having things locally and having a hybrid for being able to juggle is very important for probably the next 10 years, where we're going to have an evolving 5G cellular structure and more things we're going to demand out of our broadband.
And so, mindful of our time here, I think this tech is moving fast, and I would just reiterate, Bill had touched upon, and Luke, that it's being used at AvTech for actual training, and it's I think the future is getting ownership of it in the hands of the people that live in the communities. And that goes to a little bit what Arthur said of the laptops that we're trying to get out to students to have a look at some of the amazing things that are going on and the potential in their communities. And in terms of, if you're the manager of a utility, the manager of the water, that you start to get more familiar with your infrastructure and can share those problems and troubleshoot with folks outside the community. The logistics part of Alaska is not really going to change, but the tech is solving some of our problems. Jenny, I'm going to pop it back over to you if there's any thing in the chat or other housekeeping.
Yeah, Tammy had a good question about cost that Bill is answering a bit in the chat. So if Arthur, if you want to chime in the chat for anything else on that question, that'd be great. I just want to wrap us up with a big thank you to our speakers. That was really informative. We will share this recording when it's done processing and everything. And if you want to send me your slides too, I can share those for people who like to look at them in different ways. And also just, I know we don't have a ton of time, but if you do have any, upcoming trainings, technical assistance, troubleshooting, updates, or gaps, things you want to share with the group, you can drop them in the chat now and I can include them in my roundup. Or you can email the whole group. We are using Google Groups to sort of keep in touch. So I'll share that email in the chat right now too. So that will let everybody know if you want to share it, you know, if you're not ready to share now, but you want to share before our next meeting, that's a great avenue as well. And I wanted to put in a plug too. We talked about it a little bit the last meeting, but DEC's Alaska Training Coalition calendar is a really great resource. We started using it to post these meetings on there. We are happy to help get any other trainings posted on there as well. It's a really great repository to direct communities to if they're looking for specific trainings or you know, learnings, opportunities, things like that. So I dropped that link in the chat as well. And then we are tentatively planning our next meeting for Tuesday, June 4th at 11 a.m. I know June in Alaska is maybe not the most popular for a meeting. I think we're trying to do this quarterly, so that will be our only summer meeting. And then we'll wait until, you know, till the rains come in September to meet again. Please, you know, share or send any input on helpful topics, either to the group or just to myself and Chris. We really want to make sure these are useful for you and timely. You know, big funding announcements coming out all the time, new programs for workforce development and all these things. So we want to make sure this is a good resource. And I think that is it with a minute to spare. So thank you all so much for your time today. We look forward to continuing these conversations, and take care.
Thanks, everybody.